Hey guys, welcome back to Algos Explain. My name is David, and today we're doing I believe this is a very hard Edabit question, and I am pretty excited about it. It's a recursive question, and you know what? I think maybe I'll do more of these. Maybe focus more on recursion and trees and graphs for a while. Of course, once we get to the easy questions again, it doesn't become a topic, but every time I hit a very hard question and um, beyond, I'll try to pick up recursion stuff because it is exciting. My tongue is twisted. It is exciting, and it is the kind of stuff that people like to ask you on your interviews. Okay, so let's go ahead and get to it. This one is called ABACABA pattern. The ABACABA pattern is a recursive fractal pattern that shows up in many places in the real world, such as geometry, art, music, poetry, number systems, literature, and higher dimensions. Okay, create a function that takes a number as an argument and returns a string that represents the full pattern. Result should always be in uppercase. Okay, so that's just telling us what they want from us. Check the resources tab for more info on this pattern. And right here, there's two. This one either got downvoted or never got upvoted. But I didn't actually look through these. I thought that it was pretty self-explanatory. We can see the pattern just at a bird's eye view. We have 1A here. It looks like we are kind of sandwiching it in. Once we get to the 3, it sandwiches it in even further. And that is all I'm going to talk about it in this intro because I recorded a whiteboard. This deserved a whiteboard session, and so I'm just hoping that that audio is okay during the editing. But otherwise, I'll catch you in that one in a second. Hey guys, so welcome to the algorithm whiteboard portion of the video, and I hope that you're catching my voice alright because I'm not using a lapel mic today. I'm using a microphone that I would otherwise have on my desk, and I think it's picking up my voice. It's also probably picking up my refrigerator ringing, but maybe I'll try to edit that out. Anyway, so let's go straight to the problem. I'm excited today because it's a recursion issue, and it's pretty exciting to teach recursion because once you get it, once you think you got it, if it's the first time, then it would magically appear in your mind, and the next time you see the problem, you will remember that you don't have it. But either way, hopefully today will help you get your first step into seeing recursion. And once you see it more and more often, then it'll start coming to you. And so when I first saw this problem, I thought in the context of helper functions, and one of the topics there, I think on the problem it says recursion or something like that, so I figured, okay, it's going to be a recursive solution. But when I first looked at the problem itself, I didn't immediately think recursion. So if you didn't think immediately recursion, that's okay too. Just to recap real quick, this is kind of what they want. F of 2 read A. Alright, so when I saw this, we obviously see a pattern here. A, we have ABA, we have ABA here, ABA here. And so when I initially saw the problem, I thought maybe I could have a bigger function, which would be the function that the problem calls. And then I'll have a helper function that builds the patterns. And well, I'm glad I remembered, okay, we gotta do this recursively because that would be the wrong way to do it. Or maybe it would be the right way, that would be the iterative way. Because actually, everything you can do recursively, you can do iteratively. But in this case particularly, the recursion is pretty easy to look at. So my thought process when looking at this and thinking, okay, we gotta do recursion, I started looking for other patterns that we could take advantage of. And one thing that I immediately saw, other than the fact that, it's kind of like a mirror version of itself, A here, because it's just one. Here we have a mirror of A and B, we have a mirror of ABA and ABA divided by the C. A pattern that I saw was 1, look, see 1, and we only had one letter. 2, we have 2 unique letters. 3, no, despite how many letters we have in here, we have only 3 unique letters. And so I thought we could have like a letters array or something like that, like an alphabet array. And A, B, C, D, E, like that. And The index, we could adjust the index. This would be 0 index, 1, 2, 3, 4. However, we could, whenever we're calling something like that, we could just simply do a +1 because this pattern is not going to suddenly jump. B is never going to suddenly be a 3 or a 4. We always know it's going to be a 1. So if 1 stands for A, all we need to do is that index +1. So yes, this is the pattern that I saw. And then I thought, okay, how do we build this out? We know that recursion is, in of itself, a function that calls itself. And if it's going to call itself, it's got to be building itself. And so, it's got to be building this pattern in and of itself. And so I thought, okay, let's just do this num. And how could we go down? Well, when they give us a problem, they're going to give us a big number like this. And so we know for sure that if it's an A, we know we can end early. If it's a C, or sorry, not a C, if it's a 3, we know that the output is going to be a little bit longer. Therefore, we kind of want to go from the 3, we want to go down. And so we know that our base case here would be kind of if num is less than or equal to 0. If it's less than or equal to 0, then we can return something. And in this case, we're just going to return a null string. And so if that's the base case, then kind of that makes sense. Imagine our input was f of 0. What are we supposed to return at that point? Our base case should always solve for the last case. If they were to say if they were to give us the number as one of the challenges, like instead of giving us 1 and asking for the A, what if they gave us a 0? This base case should solve for that immediately without even having to recurse itself because of course it's already at the end. And so making sure we care for that, we built our base case. And if we were to ever we would have to ask the interviewer, are they going to give us negative numbers or not? And they would probably say no. If they don't say no, we have to check it. But otherwise, a quick checkup here, like if num is negative, then we can just throw an error or something like that. But if num, otherwise, we'd start at a positive number or 0. We took care of the 0. And so now for any positive number, we need to fill this out, right? And so how do we start building this guy out? Well, how do we start building this guy out? F of 2. We know that we have A, and we have a B in the middle. We can kind of see that the B correlates to this B right here, just an index away, and that one is 1 index away also. And what we want to do is instead of building up, like instead of going from the A, because we're obviously at the bigger number already, so if we're at the C, I keep calling the 3 a C, if we're at the 3, we can't really build up from the A, so we got to build downwards. And so one way we can do that is So we know that if it's 0, it'll go down. We could ultimately here just return f of num minus 1. What would that be? If we were given this case, f of 2, we would be putting in the A here, right? We would be looking for the A. Return f of num plus, and how do we get that? Well, we could put this outside of the scope. And so imagine that is outside of the scope here, so we could just call that here. Letters of num minus 1. Remember, we decided we're going to do a negative 1 because if we were given the 2, we want it to match with this index. We want the B, right? And so we want the B in the middle. And so 2 minus 1, that would be the index of 1. Plus, what do we put on this side? Well, we just put the other A on there. F. And that is actually the answer right there. It is pretty simple. And actually, I should have tested it out before I jumped to the whiteboard. But I'm pretty confident it is, so I might have to redo this whole video. But it makes sense. We return num minus 1 plus letters of num minus 1 plus f of num minus 1. Now this is an issue if, let's say, we only have a certain amount of letters, and so if it exceeds that, then this guy will break a little bit. It will be undefined or something like that. But otherwise, assuming that we have proper inputs, this will recurse downwards. And what I mean by recurse downwards is, see this f? Maybe I could have picked a different function name, but f is calling num minus 1, which means this function is actually just another argument here, but it's calling this guy again. And so let's demonstrate it real quick. If our original problem is f of 3, what would that look like? We would go to the base case, and num, which is the 3, is not less than or equal to 0, so we would go down here. We would return, pretty much, what would we return? We would return f of num minus 1, so that would be 2, plus letters of 2, plus f of 2, right? Because it was just those two and then the letter right in between of it. And so, can we solve for this? Well, we can solve for letters of 2. We know that that is a C. However, we don't know f of 2 yet. And so let's go figure that out. And then we can bubble up. F of 2. 2 is our argument now. And we're just doing 2 minus 1. And so see that our argument was 2. Our argument now was num was 2. And so we returned another function call of f of num minus 1, which was 2 minus 1, 1, letters of num minus 1, plus f of num minus 1. And so I wish we could bubble up here, but we can't. We don't know what the f of 1 is. So let's go ahead and solve for that. F of 0. Okay, and so at this point we are pretty much finished. A letter of 0, we kind of know that that's the end of our letters, but that actually hasn't resolved yet. This is still a function call, so we gotta do the function call. And what would that equal? Well, this hits our base case, and so we will not end up building another argument like this. We're not gonna be doing another return. We're gonna be returning within this if statement because our num happened to be a 0, and so it catches within this base case, and we return a just an empty string. Okay, and so now we can start building this out. What does this actually equal? Well, f of 0, we determined that it's an empty string, and so that's an empty string plus letters of 0, which is a. And so that's an empty string plus, and we're going to say that those are strings, plus that. And so this ends up being a, which was f of 1. Okay, and so now let's look at this guy. F of 1, what was that? F of 1 resulted to just a regular a string. And so a string plus letters of 1, which is a b, plus f of 1, which we already know f of 1 is a string a. We used it on this side, so of course it's going to be the same. This is f of 2. Now we know f of 2, and this is the action of it bubbling up. This is what actually happens in our code. And so what is f of 2? It is ABA. ABA. And it actually, this one, I forgot to resolve it. This one, ABA. It turns into this because we add the strings. F of 2. Hopefully you can see that. And so f of 2 is ABA. And so f of 2 plus this letters at the index of 2, which is a C, plus f of 2, which we solved for already, equals A, B, A, C, A, B, A. Okay, and so that is our answer. This is ABA, CABA. That is what we wanted. And so, I mean, the important part here is that if this is your first time looking at recursive functions, the key components is you need a base case because ultimately you're constantly calling yourself. This f, it stands for the function you're calling, f of num minus 1. You're just altering the argument just a little bit, and you're calling it again and again and again. And if you ever wonder what Stack Overflow is, that's what it is. It never ends. And so So that's why you need it to hit the bottom so that it can actually do that. Now, if this accidentally was num plus 1, this would have that stack overflow. It would never catch a base case because this only catches the downwards trajectory. If my num was plus 1, then it would constantly be going up. Therefore, our base case would be totally wrong. And so we got to remember, recursion, we have base case, and the whole idea of recursion is how do we call ourselves to kind of make it make ourselves useful for our bigger picture. And we start, I like how, well, of course we need to start with the base case, but also just apart from the base case, what is the initial case, which is kind of f of 1. And that's kind of how we decided to build this out. We knew that other than the base case, we had an initial case of 1, and this initial case of 2, that just one step away was this guy, but then it looks like he was stuck here. And then we took this guy, and it looked like it was stuck here and here. We took him, and it looked like he was here and here. We took this guy, it looked like he was here and here. And honestly, this empty string is actually right here and here. And so that's what happens. We took the bigger number, and we broke it down and broke it down and broke it down. We don't ever get this until we keep calling ourselves deeper and deeper until we hit the bottom. And then, just like how we demonstrated here, we go from the bottom, we actually return something, a tangible value, and that will in turn start calling this guy, and once it has something to return, this will return, and then once f of 1 returns, then now this guy, well, because once you're here, it stops and calls it, and then does it again. And honestly, I can already see an improvement to this. We don't need to call it twice, because then honestly, let's see what happens. F of 2, once we're at the f of 2, we call f of 2, and we call f of 1, right? Let me demonstrate this real quick. F of 3 called f of 2, and it called f of 2 again. We had an x there, this stands for just a simple string, and this one called f of 1. This one also called f of 1. There we go, see that? F of 0. And this one called f of 0 now 1, 2, 3, 4, 8 times. And f of 1 had to be called 4 times, and f of 2 had to be called twice. We don't need to do that actually. We can stop on one tree if we wanted to, simply by storing this as a value somewhere. We could have done that. Another way, we don't need memoization in this scenario just because we can grab that as a value within this function and use it, but the idea of memoization kind of derives itself from, it's a more complicated situation than what we're dealing with, where, like I said, we could have just simply done like let prev if we would have done a previous equals this function call, then we could have just returned the previous. And in that case, we wouldn't have had to call that twice, which then per function call, we would be calling it once. And so our tree would be different. Our call tree, this would call f of 2 once. It would be previous plus x plus previous. This would call, once it was in the f of 2, it would call f of 1 and return it, return this. I'm just making sure that this works. Do that, and with that, yeah. And so it was still, we're just storing this function call in a variable. We set that, we return it, which would be the return call of the previous one. And so this one being equal to the empty string. Now this one equals to empty string plus A plus empty string. This one is f of 1, yeah, so A plus B plus A. This is, this would have been, now this returns this call right here. This one is still previous plus X plus previous, which it was calling for that, A, B, A plus C plus A, B, A. Hopefully I didn't lose you in the last part there. I was just demonstrating kind of why my code was inefficient at one point, and I made it better by not duplicating the calls. And so let's take this, let's put it in the code, and hopefully everything works out. Okay guys, welcome back to the coding portion of this, and it is going to be pretty fast because I believe that I explained most of it in the whiteboard session. So we're just going to go ahead and knock this out. So n is our number. We're going to create our base case. If n is less than or equal to 0, we want to return an empty string. For cases that we get 0 as our first condition, this will solve it, along with the fact that it will solve when our recursion actually hits rock bottom, and at that point we'll start bubbling up. So very important for those two reasons. Mostly important because you want to bubble back up when you're doing recursion. But anyways, like we said, we wanted to do the previous thing to save some calls, and so we will take this pattern and call the previous one, which is just n minus 1, and we will end up returning previous plus this letters of n minus 1. And n minus 1 because this index is 0, and when we call 1, we want to have that actually tap into the 0th of the letters array, which is why we take the 1 if we're looking for an A, minusing it by 1 so that we actually get to the 0th index, just in case that was not clear. And we add it to the previous again. And that is pretty much it for this question. It would have worked equally. Let me just show you real quickly also that it would have worked equally if we had just decided to do this. But if you do know the fact that you can take it out like that, I would take it out. Oh, okay, it did that. I don't think I can go back and have it give my code back to me. But anyways, hopefully that was helpful to you. Like I said, if this is the first time you're facing recursion, this was a great problem. And the next time you look at it by yourself, you know, perhaps it might not make sense still. But just remember the basics, base case, and try to build it up by using the first step case, which is kind of in our situation, our base case would have been the 0, not the 1. And our first case would have been like the 1 going to 0 or the 2 going to the 1, something like that, something to build you up. And just remember, I have to call myself. And when you think, okay, I have to call myself, then you know, okay, I have to have a base case because I can't go down forever. Yeah, like that. Recursion is super exciting. It is a super exciting topic. It is a strategy. One of those strategies that you got to know, because if you get a recursive problem, it might take you forever trying to do it iteratively. And if the interviewer kind of wants that recursive solution, you would probably surprise them by doing it iteratively and also take up a lot of time, and especially if it was a question designed for recursion such as this. And so, you know, hopefully this helped you, and I'll do more recursion in the future. So hopefully when you keep on watching these videos and listening to how the strategy is developed, it might help you out. Yeah, well, thanks for tuning in, and I'll catch you in the next one. Bye.